Hello learners, welcome to another class of practical physics. My name is Biekwa Sosimakula Samuel. I am a teacher of physics. In this class, we are going to demonstrate an experiment to determine mass of an unknown mass of an object using a standard mass or a known mass. In this particular case, we have a stone. We do not know the mass of this stone, but in this experiment we are going to determine the mass of this stone by using this standard mass. We know these are two masses plus the holder. The total mass here is 100 grams. We are going to use this, and we are going to use the principle of moments to determine the unknown mass. First, we need to balance this meter rule on a knife edge. We place it on the knife edge, adjust its position until it balances horizontally. And we note the point where it balances. This particular meter rule is balancing at the 50.2 centimeter mark. Next, we are going to suspend the standard mass or the known mass, 100 grams, at a convenient place. We are going to, let's put this one at the 30 centimeter mark. We suspend it at the 30 centimeter mark, and then we get our unknown mass. Okay, we adjust its position until the meter rule balances again. So the meter rule balances again when the stone is at the 83.5 centimeter mark. Now we have a diagram here illustrating what we have just done practically. We obtained the point at which the meter rule was balancing, which is the position of its center of gravity at 50.2 at the 50.2 centimeter mark, and that is where we pivoted the meter rule on a knife edge. We suspended the known mass 100 grams at the 30 centimeter mark. Then on the other side of the pivot, we got our stone and suspended it and adjusted the position until the meter rule balanced again. And this happened when the stone was at the 83.5 centimeter mark. Now we are going to use the principle of moments to determine the unknown mass m. The principle of moments states that if a body is in equilibrium, the sum of clockwise moments about a point should equal to the sum of the anti-clockwise moments about the same point. And the moment of the force is the product of the force and the perpendicular distance of its line of action from a turning point. So we have two forces here. We have the weight of the known mass. We also have the weight of the stone. Each of these forces has a perpendicular distance from the turning point. For the known mass, the perpendicular distance is x. For the unknown mass of the stone, the perpendicular distance is y. So using the principle of moments, the weight of the known mass will be 100 divided by 1000 g, where g now is acceleration due to gravity, times the perpendicular distance of the line of action, which is x. This should equal to, on the other side we have m, okay, g, where m is the mass in kilograms of the stone, times the perpendicular distance, which is y. Now we can get the values of x and y. On this side we see that x is equal to 50.2 minus 30. This gives us 20.2 centimeters. And on this side, y is equal to 83.5 minus 50.2. And this gives us 33.3 centimeters. So these g's will of course cancel. So we want to make m the subject. So we realize that m is equal to 100 over 1000 times x over y. So this will equal to 100 over 1000 times our value of x is 20.2 divided by the value of y, which is 33.3. So this gives us the value of m as 60.7 divided by 1000 kilograms, which is equal to 60.7 grams. Therefore, the mass of this stone has been found to be 60.7 grams using the principle of moments and the standard mass of 100 grams.